Hi folks, I was looking over the homework problems from section 6.3 of the second assignment and thought maybe I should make a quick video, talk about a few of the problems since some of these may be a little tricky. So let's take a look first at number 11. So the instructions say that we need to describe this function f as the result of first applying a stretch or compression and then applying a shift. Well, the problem is if you look at the way it's structured right now, remember we don't actually follow the order of operations. If you were to look at it, you would think it might be, let's see, it looks like it might be a compression, horizontal compression by a factor of 3, and then we shift right 2. But remember, we don't follow the normal order of operations when it comes to horizontal transformations. We actually follow the reverse order of operations. So the way we're looking at it, we would actually need to say we're shifting right 2 first, and then we have a horizontal compression by a factor of 1/3. All right, but that's not what they want. They want it where we have the shift last. All right, so hopefully you remember from what we said in class today that we need to do something with this 3 so that we can read it as a shift that comes last after the stretch or compression. So why don't you pause the video and see what you can do to make it look that way, and then you can check and see what I've done. All right, check and see if this is what you got. So what we learned in class today was that if we factor this 3 away from the x, so that we just have it as a single x, and then of course we're also going to factor it away from the negative 2 there, then we can just read it so that the shift comes last. Even though now it looks like we should do the shift first, the fact is we need to do it in the reverse order of operations. So now you can describe the stretch or compression first, followed by the shift. All right. Okay, let's also take a look maybe at one of the parts of number 15. All right, we've seen some problems kind of like number 15 here, where we know a certain point is on a function, and now we want to figure out, what point would have to be on this new function that's a transformation of the old one. I decided, the book just writes g of 2x minus 5 for part A. I decided let's just call that a new function h of x, all right? And now we're trying to figure out what point is on h, all right? Well, my advice for this, I know we've done maybe a couple problems like this. My advice is always, I think it helps if you'll just write out the transformations for the given function, and then you can just apply them to that point. Just like you might for a graph, you need to figure out what are we doing to change the graph. So maybe pause the video and see and write out the transformations, and then see if you can get the new point from there. See if this is what you got. Now these two transformations, it really doesn't matter what order you do them in, but I'm just kind of in, because one of them's horizontal, the other's vertical, I'm just kind of in the habit of doing the shift last. So what we first have with the 2, right, is a horizontal. This would be a compression by a factor 1/2, opposite of the way it looks. And then we are going down 5 because we're not applying it to the x part. So this would be a vertical change, shift down 5. All right, so if you're compressing horizontally by a factor of 1/2, right, you're only going to be affecting the 6 on that. So we just need to multiply that 6 by 1/2 to get 3 for our new x coordinate. All right. And then for the shift down 5, that's only affecting the y coordinate, so we just need -9 minus 5, and that would give us -14. All right, so I think the new point here, if you want to check me on that, but I believe the new point is 3, -14. Here, I'll write it in here. Okay, so there's the work for it. Gives us our x coordinate and our y coordinate, and there's our answer. All right, probably the scary part about number 15 is letter C, where you have this formula, and now you have to kind of do the same thing. I will point out that one nice thing is they do have this set up well for the horizontal stuff. You can see the x is already kind of by itself. We've got that 1/3 factored out. So I think we're good here just to do the shift last, all right? The only other thing you might want to deal with is when you go back and look at your notes, you notice we didn't have parentheses around the G part, okay? So let's get rid of those parentheses by distributing that negative, all right? But keep in mind that negative is not going to come inside the G, all right? You can't do that because you don't know what G is doing. It could be the squared function. It could be, any kind of function. So you can't bring the negative inside there, but you can distribute it along the outside, all right? So if you do that, you'll have the following. There we go. Now we have our we have our negative on the G, but we distribute it all the way across to the -8. So now we have +8. And I think now you're ready. You can write out the transformations and then apply them to 6, -9 to get your answer. So one final thing I'll just say about number 13C, which is on your assignment, is, as soon as I see this, I'm noticing, all right, we got the issue with too many horizontal things going on. So this would be another case where probably be easiest if you just factor that 2 out from the 2x and the 1. You don't bring it outside the f, but just factor it away, and then you can just do your shifts last. All right? So good luck with the rest of the homework. I hope this video helped.